So this is 7-1, and we're looking for the moment of inertia about the y-axis here. And so to find this, we know we have a constant density rho and a constant area A, and this length is L along the x-axis. And so what we're doing here is using our equation Iy is equal to integrating over m r squared dm. Now remember, if rho is constant, the density is constant, we can pull that outside the integration and we get rho integrating from over the volume now, r squared dv. And the reason we can do that is mass is equal to rho times the volume here. So if by changing mass to volume, all we need to do is pull that rho outside here, and that's a constant. All right, so let's take a look at this differential element. So along this tube or pipe, we have a small differential element here. So let's just take a look, and kind of the thickness of that is dx, just a small bit of x. The area here is A, and the distance that that is acting along is actually x. So in our case, r is equal to x in this equation. And the small differential element, right, is the area times dx. So subbing this all into this equation up here, we have Iy is equal to rho, the integration, x squared a dx, that's our differential element here. And we are going to integrate that from 0 to L. We're going to integrate x from 0 to L. So from 0 to L here to sum up all this whole shape here. All right, we know that A is a constant, so we can pull that out along with our rho. So we have rho A integration from 0 to L x squared dx. Now performing that integration, we have rho A, and then integrating this with respect to x is x cubed over 3, and then we'll evaluate that from 0 to L, our bounds here. Okay, so that comes out to rho A L cubed over 3. Now this problem wants Iy in terms of mass. So we must notice that rho times A times L is actually the total mass of the object. So the density times this cross-sectional area times the length, all right, is the mass, because the area times the length is actually the volume, right? The volume, and the density times the volume equals the mass. So we're going to pull out rho AL from this equation here, and then we just have L squared over 3. So we know that this term is mass. So Iy comes out to be mL squared over 3. And that is our answer. Iy was mL squared over 3.